What if the most advanced telescope ever constructed has revealed something we were never supposed to witness? What if the foundations of everything we believe about the universe's origin, about time, space, and the nature of reality beginning to unravel in light of new findings? The James Webb Space Telescope, created to observe the earliest light from the formation of the cosmos, has transmitted data so unsettling that a renowned physicist who once held firm beliefs has come forward with a chilling statement. This is not our universe. The question now facing the scientific community is profound. What exactly has the James Webb Telescope detected at the farthest edge of existence? And why are experts warning that these revelations could fundamentally alter our entire understanding of cosmology? In a remote portion of the sky filled with ancient light, the telescope recorded what initially appeared to be a faint yellow blur. Yet, when astronomers examined it more closely, their assumptions collapsed. That small glow wasn't just another galaxy, it was the most distant galaxy ever identified, formed merely 290 million years after what is believed to be the beginning of the universe. The issue is that it's far too large, luminous, and mature to have developed so soon after the Big Bang. According to current models, there wasn't enough time or matter available in the early universe to give rise to such a structure. And yet, it exists, and it isn't alone. Webb has uncovered dozens more with similar characteristics. Each one defies our understanding of how the early universe should have behaved. The deeper researchers looked, the stranger the findings became. Some of these early galactic structures aren't merely enormous, they appear completely unlike anything previously seen. While ordinary galaxies tend to convert roughly 10% of their gas into stars, Webb found at least 3 examples that seem to have transformed 100% of their matter into stellar bodies. There is no remaining gas or dust, only pure, radiant starlight. This isn't merely unusual. It's impossible by any standard model of galaxy evolution. As a result, scientists are now confronting far more unsettling questions. Are these really galaxies at all? Is it possible that we're not looking at the early universe, but at something entirely different, a structure from a different dimension, a fragment of a previous cosmos, or a disturbance from another universe? To grasp why these discoveries are causing a fundamental shift in cosmology, we must examine the concept of the Hubble sphere and the limits of the observable universe. The farther away an object lies, the more quickly it recedes from us due to the universe's expansion. Beyond a certain threshold, the Hubble sphere galaxies move away faster than the speed of light. In theory, we should not be able to observe them, yet we can. This is because the fabric of space itself is expanding, extending the boundary of what is visible. But beyond that boundary lies a disturbing notion, a region we can never reach, and that can never reach us. Despite this, Webb has now detected signals and light from these unreachable realms like that, by every current model, should never have arrived. This suggests something extraordinary. We may be observing regions beyond the known universe, and what lies beyond remains unknown. The implications are profound. Webb's findings are prompting scientists to consider ideas previously dismissed. What if the universe never had a beginning? Some physicists, including Nobel laureates, are now questioning the very idea of the Big Bang. If galaxies can form faster than physics allows, if light reaches us from unreachable distances, and if structures appear that disregard known limits of time and mass, then perhaps our entire cosmic narrative is flawed. Maybe the so-called early universe is not early at all. Perhaps what we are observing is not a temporal sequence, but a rupture in reality, a point where two different universes converge, or worse, a space where something far older than our universe is seeping through. Among the James Webb telescope's lesser known but most mysterious discoveries is not a visual phenomenon, but an unusual frequency. While measuring the cosmic background, the telescope's sensors picked up a faint, rhythmic vibration. This signal does not match anything known. It is not a pulsar, not a gravitational wave, and not a distortion in the cosmic microwave background. The pattern repeats at exact intervals, suggesting it may be intentionally generated. Some researchers refer to it as the heartbeat beyond time. Others, more reserved, suspect it could be the trace of exotic matter, something that only exists outside our universe's constraints. Most unsettling is that this rhythm isn't random. It follows a precise mathematical structure, as though encoded deliberately for detection. Another puzzling observation involves a discrepancy between visible matter and gravitational influence. Galaxies at extreme distances appear to exert gravity strong enough to bend light, distort surrounding space, and affect nearby systems. Yet no visible mass accounts for these effects. This doesn't align with typical explanations for dark matter. Instead, it suggests the presence of vast, unidentified, gravitational forces. Some theorists now propose that we may be witnessing the influence of another universe pressing against our own cosmic imprints from a realm we cannot perceive. Could it be that everything we observe has an unseen counterpart, not metaphorically, but physically? A once dismissed hypothesis is gaining renewed attention. The idea of a mirrored universe where time flows in reverse and physical laws operate differently. What has changed? The James Webb Telescope has recorded strange particle dynamics and rotational anomalies in remote galaxies that hint at asymmetry, as if the distinct cosmic systems are interlacing. It seems as though our universe is being tugged in one direction, while another, hidden one, is pulling the opposite way. If accurate, this could mean we are not isolated in the cosmos, but entangled with a shadow realm that reflects our own in reverse. In a final and enigmatic observation, one of Webb's long-range sensors tracked a beam of light from near the edge of what we believe is the observable universe. Scientists expected the signal to fade and vanish, as most ancient light does, but then, inexplicably, it reappeared not from the same location or moment in time, but with an identical spectral signature. It was as though the light had been sent out and returned, as if bouncing off something. What could reflect light from such a distance? There are two possibilities. Either the light curved around a closed, finite universe, implying that space loops back on itself, or it encountered something at the edge, a surface or structure capable of reflecting light. Whatever it was, it should not exist. The James Webb Space Telescope was designed to illuminate our origins, to glimpse the infancy of the cosmos. But instead, it may have uncovered something far more disturbing. Its findings suggest that our universe may not be singular. The anomalous galaxies, the unaccounted for gravitational fields, the mirrored cosmic patterns, the rhythmic signal, and the returning light all point to a reality that challenges the idea of a self-contained universe. A highly regarded physicist has stated, "This is not our universe," and perhaps that's the reality we were never prepared to accept. It's possible we are adrift on the periphery of something older, vast, and fundamentally beyond comprehension, a deeper framework, a broader existence, a universe beyond what we have known. Now, the pressing question may no longer be whether we are alone in the universe, but whether we are even in the correct one.